Here's Algebra 2 with trig, section 2.7. This is the second day on piecewise functions. We're going to look at a piecewise function here, and we're going to write the piecewise function for what is being represented from our graph. We notice that these are segments. May not be clear, but we have a solid dot, and then we have open circles. So this line here would be y equals 1. This one would be y equals 2. And this here would be y equals 3. So in our function, we're going to use y equals 1. What x values are we using that for? Whenever x is greater than or equal to, because it's a solid dot, but less than 1, we're going to be, sorry, you don't put the y equals there, you just put the 1. We're going to use the 2 whenever we're from 1, which includes 1 because of the solid dot, all the way up to 2. And then we're going to use the line of 3 whenever we're at 2, greater than the 2, all the way up to the 3. So this piecewise function represents our step function. What's the piecewise function for this given graph? We have to look at what each of these equations are. We have to figure out the y equals mx plus b for each of these equations. So you got to look for the values that you know for sure. It looks like it has a slope of 1, 2, 3, 1, 2, 3, down 1, backwards 1, down 1, backwards 1. So this first equation has a slope of -1. The y-intercept is b equals 4. So one of our equations is y equals -x plus 4. That's one of our equations. You could put it right next to it just to help you organize. Our second equation, got to look carefully at where we're sure we have values touching. Looks like here would be the only spot. Up 2 over 3, up 2 over 3, and it touches again. If you're not sure about the slope, then test it to see if it's definitely hitting. You don't want to say something improperly and then find out over time it really falls off. It should stay right in line. So in the second equation, I have a slope of rise up 2 over 3. The only trick here is I don't know what my y-intercept would be. Maybe I could follow my slope down. That can work. But we can also use y equals mx plus b and solve for our y-intercept. We know the point for sure is at 3, 4. The y value is at 4. The slope we said was at 2/3. And our x value was at 3. We're trying to figure out what the b value is. So we could get 6 divided by 3 is 2, or cross the 3's out to get 2, plus b. Subtract the 2 to the other side. We have a y-intercept of 2. So now I'm ready for my final piecewise. I have my first equation up here, -x plus 4, and my second equation, 2/3 x plus 2. So I know what the equations are. Now the domains. When are we on this equation? It looks like we're on this equation whenever we're looking to the left, which is less than 3. So we're on this equation when x is less than 3. Seems like we're on that equation whenever we're greater than or equal to 3. So you're noticing that the x value is 3. We're going to the left, which are smaller x's. We're going to the right, which are larger x's. So greater than 3 for a positive slope, and less than 3 for our negative slope. If you have 3 equations, you just have to know the equations of all 3 lines. This one here seems pretty easy. It's y equals 2. Here we have the 2 endpoints. We have a slope of up 1, 2, 3 over 1, 2, 3. So that's still a slope of 1. You could either continue the slope on, up 1 over 1, 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 up 1 over 1. It looks like we land at 7. That's one way you can do it, as long as it lands right on it. So we're going to get an equation of y equals x plus 7. It has a positive slope because it's increasing to the right. And it looks like if we extended it, it would cross at 7. Let's look at this equation. This equation, looking at our 2 points that we know for sure, rise 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. Looks like we're going up 8, negative 4, which would be negative 2 slope. Up 2 over 1, up 2 over 1, up 2 over 1. Yeah, it's following that slope. You should be able to test it to be sure it works. Now we want to look to see where does it cross the y-intercept. If we continue this slope on, we're going to fall off our grid. Somewhat difficult to find. So instead of trying to approximate the answer, I'm going to use y equals mx plus b. Pick a point. We can use 4, 6. 6 for the y. Our slope is negative 2. 4 for the x. This becomes negative 8. And when we add the 8 to the other side, we get this b value to be 14. So I'm ready to write my piecewise. So I have my function of x plus 7. I have my function of 2. And I also have my function of negative 2x plus 14. Now, when am I on this equation? I'm on this equation when we're at negative 6 all the way up to negative 3. So greater than or equal to negative 6 but less than negative 3. Because we have an open dot there, we know that that does not include the negative 3. The equation of 2, its domain is going to be for all the x values that are greater than or equal to negative 3 all the way until you get less than 4. The open circle happens at 4. It's open, so it's less than. It doesn't include it. And then our final equation we're going to be at 4. X has to be greater than that because its X value is bigger than 4. But we go all the way up to 8. So notice there's no arrows on the ends of these, so they all are going to end. Our final example is writing our piecewise here. We notice that this piecewise looks a little bit different than the other ones we've done. What do we suspect that this is going to be? Looks like a V shape, so it should be an absolute value. As long as the slopes are opposites of each other, then it's truly going to be an absolute value. Let's see what we get. This slope looks to be up 1 over 1, up 1 over 1, up 1 over 1. So this slope is definitely 1. With a y-intercept at 3. This slope over here looks to be -1. And if we continue that slope on, we're going to land at 1. So I might be ready to write our equation right now. Our piecewise function, if you want to use function notation, say f of x equals, we often start on the side, so we're going to be -x plus 1 and our other equation is going to be x plus 3. Our domain for this is, we could cover that up. We're going from this x value to the left. That happens to be at -1. So x is less than -1. We have a positive slope when x is greater than or equal to -1. Now you could have included this equals up here if you wished. Say that it's part of our second equation, but then you would not have included it on the bottom. It doesn't matter which one you include it on, you just can't include it on both domains. You want to be sure that it's a function, and when a piecewise is a function, you know which train, you know which equation you're going to be on for every value of x.